1399 called largest group. So for this problem, I'm going to use two methods to solve it. So the first method is going to be a brute force, and the second method is going to be DZDP. So we're going to compare the time complexity, and we're going to try to understand why we're going to use the second method, why it is better, why the DZDP is better than the brute force. So for the brute force, let's just prepare a counter first. And then we're going to check all the numbers, so from 1 to n plus 1. Now, let's just prepare a result. It's going to be the sum up of all the digits. It's going to be the integer of n. Maybe we're going to use the integer. Yeah, let's just use some other characters, maybe integer of j, for j in string of I. And then we just use the counter to update the counter. Yeah. Now we're going to check a maximum value. It's going to be the maximum of d dot values. Yeah. So the last is that we just need to turn d dot values into a list, and we're going to just try to use the count how many of this maximum values. So this is going to be the brute force method. Let me just run it and submit it to check if it works. Yeah, as you can see, it works and the speed is okay. And for reading like 1300, so this is okay, and this is an easy problem. And the time complexity is dependent on this. It's going to be on 10 to the power of 4 times here. The sum of the digit is going to be basically 4. Yeah. So this is going to be the time complexity. Basically, it's going to be 10 to the power of 4. Yeah. But what if this n equals to 10 to the power of 9? Or 10 to the power of 15. How can we solve it? Definitely we cannot use the brute force. So this comes to the idea of DZDP. So now we're going to use the DZDP to solve the problem. So first of all, we're going to turn this number into a string, and then we're going to use the template. So we're going to use index I, and here inside I'm going to use a total, and it's a limit, and it's none. So if I equal to length of the string, I can return 1 if total equal to 0. Otherwise, I'm going to return a 0. I'm going to set a result to be 0, and if not, it's none. I'm going to update the result. It's going to be f I plus 1. Total going to be the same. Its limit going to be a false, and it's not going to be false as well. Yeah. Now I need to prepare two variables, low and high. Low going to equal to 1 if it's none, else it's going to be 1. And high going to be the integer of si if it's limit. Otherwise, I'm going to set it to be 9. Now I'm going to check all the digits from low to high. And I'm gonna update the result. Gonna plus equal to f. Here gonna be I plus 1, and this total gonna be total minus. Yeah, because for this total, I'm gonna prepare all the numbers like from 1 to n. Maybe not from 1 to n, because total is the sum up of all the digits. For example, if there are like 4 numbers, it's gonna be 4, 9. Yeah, maybe it is just 36, that is okay. That is why we can pass. That is why it is fast. Because for this total, the maximum number is just 36 if it is 10 to the power of 4. If it is 10 to the power of 9, maybe it is just 81. It is still a small number. It means it is the log n time for this total. That is why we're going to use it. Yeah. So this I is also similar like log n, and this is also like log n. Yeah. That is why we're going to use the DZDP to solve the problem. Yeah. This is going to be total minus d, and its limit going to be its limit, and d going to equal to high or not. Yeah, and the last one going to be true for its num. So finally, we're going to return the result. Now we just need to prepare the final answer. Yeah, because for this function, we just need to put the total inside it. Yeah, we just need to put the total inside this function to check the final result. Yeah. So let me prepare a result and maximum value. it's going to be 0. Now let's just check all the possible values. So for I in reads, I think 50 is enough because the maximum number is 10 to the power 4. So maximum we're gonna have 49. It's gonna be the maximum. 36 is enough. So here I'm gonna prepare 50. I think it is enough. So the answer gonna be f with 0. Yeah, let me just use a target. Maybe it is better. Yeah. So here we're gonna use a target. So the target means the sum up of all the digits. Yeah. So as it is starting from 1, so we're gonna starting from 1 to 50. Yeah. So the answer gonna be f0 with the target, and its limit gonna be true, and its num gonna be false. Yeah. If the maximum value more than the answer. So the maximum value, yeah, I did it wrong. If this answer is more than the maximum value, so the maximum value gonna be the answer, and the result gonna be 1. And if this answer equal to the maximum value, so I'm gonna update the result. So finally, I just need to return my final result. Yeah. So this is the basic structure of the DZDP. And basically, this is just a template. For here, up to here, this is just an easy problem. Yeah. Now let me just run it to check if it works. Now as you can see, it works. Now let me just submit it. Yeah, as you can see, it passed for all testing cases, and it is much faster than before. Maybe we can also use like 37. That is also enough for our calculation. Yeah. Yeah, as you can see, it is much faster. Maybe we can still use something like, yeah, but I don't want to optimize that. I think that is enough. We're gonna just use a 50. I think 50 is big enough for us to solve the problem. Yeah. Now, what I wanted to say is about comparing the time complexity. Yeah, because for this total, that is just the sum up of all the digits. So it's gonna be log n time, and this I is just the number of the digits, so it is another log n, so it's going to be log n square. Yeah. And inside, so this is just a for loop, so this is another 10. Yeah, basically I think this is going to be the time complexity, so 10 times log n square. So log n gonna be around let's see. Yeah, so this is like from 1 to 50. So 50 times 10 times log n square. So this is going to be the time complexity. Basically, it's going to be 50 times 10 times 100. Yeah, but still it's going to be a small value. That is why it's so fast. So this means even it is n equal to 10 to the power of 9, it is okay, because log n, basically it's going to be like 30 times 30 times 10 and times 50. We can still pass. That is why we're going to use this method. Yeah. This is 900, 9,000, 10 to the power of 3, 5, 10 to the power of 1. So basically it is 10 to the power of 5. So yeah, even this n gonna be 10 to the power of 9. But even this n equal to 10 to the power of 15, we can still pass, because this is the DZDP to solve the problem. Yeah, I think that's all about it. Thanks for watching. See you next time.